I'm gonna start recording from now. I think the only thing that they missed was what, this part, right? The 3 reasons
And the part before.
and the infinity. So I would just
Do you have any Band-Aids?
both know us. I do. I'm gonna get after those. I'll give you them. So both Noahs. All right. Sorry. Sorry, Noahs. Sutton won't care. I'll get Garner. Yeah, I'll get Garner cut up. All right. What we're doing today kind of goes along with our very first limits poster over here. So all y'all's calculus posters I will put along this wall, and we'll go in order, hopefully, and I will just kind of go along the wall as the year goes. And you saw them last year, so yes, it will fill the wall up. So on this guy here, we are starting to solve limits not with graphs, not with tables, but by hand using algebra. All right, so if you start with your limit, the very first thing you do, which is the first thing we're going to do, is direct substitution. So as x is approaching a number, the first thing you try is direct substitution. All right, we're going to talk about this stuff later. So we're doing this today. X is approaching a number. The first thing you try is direct substitution.
So we haven't learned anything on that.
No, you haven't learned anything on this. All right, so basic limit. So we are going to directly substitute here. Now, is there anywhere to plug 2 in? No, so your limit is just 3.
What?
And then
Yes,
the
it
next
does.
one is -4.
Think about what the graph of 3 looks like. The graph of 3 is a constant line at 3. So no matter what number we approach here, my limit would be 3. Does that make sense?
That's easy.
That's what, yeah, because.
It's like too easy.
All right, it's gonna get harder.
The next one's -4.
So here we are going to directly substitute -4 in, and so your limit is -4.
So you're telling me we could have figured out the limit like this was in class?
If you had a function, yeah. If you're given a graph or it just says f of x, it doesn't tell you what f of x is. Yep, so here we're gonna plug this in, 2 squared, which is 4. So if you can directly substitute, that is always the easiest thing, do that. You'll see. You'll see. We'll come to the instances where you can't do it. What's up? Yeah. Leave the door open because I think it's locked right now. All right, so here we're gonna plug 2 in. 4, 2 cubed plus 3. What is 2 cubed? 8.
Wait, we have to do this, we have to know how to do this by hand.
You should know what 2 cubed is, yeah. All right, 4 times 8, which is 32, plus 3, which is 35. All right, then we're gonna plug 0 in. 2 times 0 minus 1. -1. Then we're gonna plug 3 in. 3 plus 1. 4, which is square root of 4 is 2. Do I need a plus minus? No, so only if you take square root do you need a plus minus. Square root's there, it's just whatever side it is. All right, flip it over. You are gonna have trig, and you could have trig on your homework quiz. So tangent of 0, remember tangent is sine over cosine. No. We have 10. All right, I still don't have very much time to do what I want to do. So on here, what is the y value at 0? 0. What is the x value at 0? 1. So what is 0 divided by 1? 0. 0 divided by 1 is 0.
If it was 1 or 0, it'd be-
Yeah. That's what tangent is. You should just know that. All right, now we're gonna plug pi in.
It's also on here.
Pi times cosine of pi. So on your unit circle, and for the record, this stuff would be on a non-calculator portion of the test. You cannot use the unit circle on the AP test.
I just.
All right, so pi Now, for a while in this class, I'll let you use your formula chart. I probably will take the formula chart away second semester. All right, so you can still, you have a semester to memorize the unit circle if you didn't do it last year. All right, so pi is right here. Cosine is the x value, which is -1. So pi times -1, negative pi.
Hold on. The pi comes to -1.
Yep.
Oh, so it's on the unit circle or whatever?
Cosine of pi is on the unit circle, which is -1. So pi times -1 is negative pi.
So how are we gonna know when we're supposed to solve, like what we're doing right now versus what we've been doing?
What we've been doing had graphs. We didn't have functions on what we had before.
Well, we're just solving for limit.
Yeah.
Can you just graph it, go to the table?
If you had a calculator.
You multiply cos squared pi twice, so one pi.
This is cosine of pi. It's not just a pi, it's cosine of pi. Cosine of pi is -1.
Oh.
All right, last one, sine squared of 0. Well, this is the same thing as saying sine of 0 squared. 0 is right here, sine is the y value, which is 0. So 0 squared is just 0. You can't square the 0 and then do sine of 0. You have to do the trig first and then square it. It's sine of 0. Yeah. All right, let's keep going. So y'all are all asking me, or at least I think Elijah is, why can't we just do this every time? Because if you directly sub in and you get 0/0, very good. That means you got to keep going. It is not undefined. It is not 1. It is not, does not exist. It means you have to keep going. It means you do not know what the answer is.
Is that why you were saying it's nothing?
Yeah, it's nothing. We have to keep going. And so we're going to keep going in 2 ways. And I'm going to skip around here because we are running out of time. The first way is going to be to factor, all right? Which you should know how to factor. So if I were to directly sub in 0 here into this limit.
What if you plug it in the calculator and it says undefined? Or what if like in reality it's 0? Would the calculator say undefined if it's 0/0? What would the calculator say?
Yeah, it says undefined, so don't trust that.
I know.
Plug in, and when you get 0/0, then you know how to factor. So yes, so we are going to plug in first, because if you can plug in, that's always the easiest way. And when you get 0/0, you know you have to do something else. So if you look at your chart over here, there are all kinds of methods that we're going to go over when you get 0/0. All right, so when you get 0/0, we have factoring, complex fractions, distributing, conjugate, and squeeze theorem that we're going to talk about for today and on Monday. I know. I'm going to go to the bell, so just keep that in mind. After class, yeah. All right, so factoring, we are going to pull out an x squared because that's what's in common here. And you get x squared minus 5 and x squared on bottom. So what can you cancel? The x squared. And so I have the limit as x approaches 0 of x squared minus 5. And so once you have factored and canceled something, then we're going to try to directly substitute. So when you directly substitute in, I get 0 squared minus 5, which is -5. So your limit is -5. So the method is to factor, cancel a common factor, and then directly substitute.
You go through the factory part again.
I'm going to do another one.
So if it's 1/0, it's still undefined.
No, 1/0 is something else.
What?
All right, so here, when you plug this in, you get 0/0, which means we got to keep going.
How do you know always we're getting 0/0?
I can do it, man. -3 squared is 9, -3, which is +6, -6, which is 0, -3. Oh, and that's supposed to be a plus. Yeah. -3 plus 3 is 0. So what multiplies to give me -6, but adds to give me 1?
Why do you have the negative arrows?
Why do I have what?
The X arrows. Wait.
Oh, I don't know.
It should be 3, right?
Yeah, it should be -3. +3, -2.
Yeah.
That better? Yeah.
Mm.
Okay, and then on the bottom is x plus 3. So I factored the top, I factored the bottom, and so what cancels?
X plus 3.
Good, and so now I have the limit as x approaches -3 of x minus 2. And so now when you directly sub in -3 minus 2, which is -5.
Okay, so when it's 1 over 0 or 0.
We're not talking about that today.
Are all the answers gonna be -5? Wait, why aren't we talking about
We're not doing that today.
that? Number 2.
Is it?
Yes.
I gotta look then. All right. Go to distributing, because I want to at least do one of these guys so you can do your homework. All right, distributing. I have to skip through factoring because I don't have enough time. But it's basically factor, cancel a common factor, directly substitute. So it's not that bad. All right, distributing is basically what it says. If you plug something in, so we're going to plug in 0 for delta x. And so I get x squared minus x squared on top, and I get 0 on bottom, which is 0 over 0.
Wait, what? Hold
Look,
on.
I'm plugging in 0 for delta x.
Why?
Because you always try to directly substitute first.
Okay.
When you get 0 over 0, it means you got to keep going.
But you can't plug that into normal X, just delta X?
Just delta x. Yeah. Delta x and normal x are two different things.
Okay.
Oh, I see. It says delta X.
Yeah. All right. So when you are plugging in 0 and you get 0 over 0, it means you got to keep going. So we are going to distribute this all out. I can't factor it. It's already kind of factored out. So I have to do a different method. And so another method would be just multiplying everything out. So when I multiply this, I have to FOIL x plus delta x times x plus delta x. And it does get kind of weird because of all the x's. So x times x is x squared. X times delta x is x delta x. And then you get it again, x delta x. And then delta x times delta x is delta x squared. Yeah, it's a lot of x's. Yeah. So I can combine the middle. So I'm going to write this as x squared plus 2x delta x plus delta x squared minus x squared all over delta x. Yeah. These guys get crazy. So from here, stuff should cancel. So once you have distributed everything out, you should be able to cancel some things. So what can I cancel?
Isn't that supposed to be mine? What? Where'd you get that? Oh.
All right, so I can cancel out the x squareds. So then now look at what every single term has. Right, or you can just cancel it out. Either way.
Every single term of delta.
So I'm going to cancel a delta x out of every term.
2x.
2x
plus 2 delta x.
just plus delta x.
Isn't that 3 delta? Isn't that 2 delta?
We canceled one of them out.
No, the other side.
Here. 2x delta x, I canceled it, the delta x.
Out of both of them?
Delta x, out of, you have to cancel out of every term. Okay, so now if we directly substitute, where are we plugging in 0? Into the delta x. So this is still going to say a 2x plus 0, which my answer is 2x. Okay, wait, let me tell you what to do on the homework. And I'll send out the key and I'll double check the ones that maybe I didn't go over today. 1 through 21. 1 through 21. Yeah, I don't think you need a calculator for it. If you want to take one, you can though. All right, 1 through 21. Oh, 1 through 20. I think I took off 21. 1 through 20. I will send out a key. Come with questions. All right, specific homework questions, not like I want to review before your homework quiz.
Yes, please.
Okay, and then because I messed up in the beginning for you Noah's, for these guys, this is just saying positive infinity is going to the right. So as I'm going to the right, you can come in, I'm recording. As I'm going to the right, your graph is forever going down, so that's why it's negative infinity. As you're going to the left, your graph is forever going up, so that's positive infinity. And occasionally you'll hit asymptotes, which is what these guys are. So as we're going to the right, my graph is forever getting close to 0. And as I'm going to the left here, this one's also getting close to 0. These guys are getting close to -3 on the left and the right. So when you're approaching positive or negative infinity, that just kind of is talking about your horizontal asymptotes. And then the 3 times the limit doesn't exist, you can jump, which your graph will break apart. And that specifically is a piecewise function. You can have infinity, which is just a descriptive way of saying doesn't exist, which is a vertical asymptote. And you'll get that when you have x on the bottom of your fraction. And then you'll have oscillating, which happened on one of your homework questions, I think, and it'll just look crazy in the graph. It'll just go back and forth like that. Here's an example if you want to graph and see what it looks like. You won't have to look at this and know that it's oscillating, but you will have to maybe look at a graph or graph this and look at the graph and see that it's oscillating. So it won't ever be something that you'll have to know how to graph by hand without a calculator. So this would be like a calculator question. And then I think we hit everything else.